If you click this video away, then please tell me what the reason for it was so that I can improve. Otherwise, hi and welcome. I'm trying to learn particle physics. Today is the Higgs 2 dull, and after we've done with it, we're gonna do standing yoga. And if you participate in the standing yoga, then is that at your own risk. For half a century, finding the Higgs boson was top of particle physicists' to-do list. But a decade on from its discovery, the way it is conforming to all expectations is increasingly causing headaches. Okay, for 50 years, from the 1970s to the 2010s or something, 2060s to 2010s, they were searching for the Higgs boson, but then they found it. I'm not really able to say it so fast. So they were accelerating the protons and the other protons, banging them together, and then they were catching these scattered fragments of it, and they were able. The Higgs boson is also expected to decay into where was it? The Higgs should sometimes decay into pairs of high-energy photons. Because momentum is conserved in particle decays, the momentum of the photons can be translated into the mass of the particles that produce them. So they were catching the photons, which happens after the collision with some types of catch things, these photons. And then they knew now exactly where the photon's momentum was, where it was going on, and how much energy that Higgs had. And so we could find where is the Higgs, we could find the remnants of Higgs. So we found the Higgs. But now we found the Higgs around 2012 or something, 2012 on the 4th of July. And now it is conforming with all the expectations what this Higgs should do, and that is causing headaches for some reason. Let's read it. In its most simplified form, the standard model comprises an equation with 4 terms. The first describes the 3 forces within the model: electromagnetism and the strong and weak nuclear forces. The second sketches out the elementary particles and how the forces act on them. The 2 final terms are only just being written now. They largely tell the story of the Higgs boson. Okay, we have still not we want to go over that whole book again, probably, because I don't have another one. And when we're going to do exactly about it now, knowing a bit more, then we try to really say and find out what is electromagnetism, what's strong nuclear force, weak nuclear force, and so on. So the electromagnetism, one of these forces holds the quarks inside the protons together, another one acts between them all, and another one does something else. So that are the first descriptions, and then the other laws is about how many the elementary particles, how the forces act on them. That there are different types of particles in them and how these forces are acting on them. With quarks having 3 of them and 1 proton and 1 electron, but they are plus and minus 2/3 plus and 2/3 plus and minus 1/3 or minus 2/3, and that the thing is now a little bit charged and so on, and all these things and how these forces are acting on them. And the third and fourth one are about the Higgs boson. The Higgs is connected to many of the most troublesome aspects of the standard model. It is the linchpin for the ramshackle arrangement of particle masses, varying according to how strongly the Higgs couples to them. I don't know what a linchpin is or a ramshackle. Electrons, for instance, are far lighter than their sister particles called muons, which are far lighter than their siblings called tau particles, and no one knows why. It's so chaotic, says I don't really know how to pronounce that name in English. Beard Heinemann at the University of Freiburg in Germany. The standard model has all these numbers in it that we don't understand. There are no laws for them. It's like the Wild West. The electrons are very light, far lighter than the muons. The electrons are light, far lighter than the muons. But the tau and the tau is much lighter than the muon. Electrons are lighter than muons, and muons are lighter than tau. So who's now how heavy? Whatever, some of them is heavier and some is not so heavy. And the rules for them are like the Wild West. So physicists hate putting numbers into theories by hand, as opposed to those numbers emerging naturally from a theory. Fine-tuned and ad hoc are insults in a field that seeks to discover the most basic order of reality. It's like gravity would act differently on apples, on humans, and on planets, says Heinemann. Because they're having different weight, that's what we're talking about. But doesn't it make odd sense? Or did we just have oversimplified it? They are just heavier as the other one, because of the different forces acting on them. But maybe it doesn't work out, just because we have oversimplified it works. If someone writes it now exactly down, it doesn't fit even if you calculate all the different forces, and maybe that's what we're saying. It's just so unsatisfactory. What is the origin of these numbers? The only difference between electrons, muons, and taus in the Standard Model is the way they interact with Higgs. The mysterious origin of particle masses suggests that some deeper structure exists, which studying the Higgs in detail may reveal. Okay. So the Standard Model says the difference between these electrons, muons, and taus, which vary so starkly or drastically in their weight amount, is because of the Higgs boson. And that whole thing has maybe something to do with a deeper structure that can be found out if struggling with the Higgs boson. The idea is that by precisely measuring these interactions, we will see inconsistencies that the Standard Model can't explain, offering clues towards a new, further-reaching theory. The Standard Model explains the electromagnetism, the strong and the weak nuclear force. Maybe what we're saying is there's a fourth force which is not understood. We were talking quite a lot about the matter and antimatter, and that there's maybe a field acting on them or something. That doesn't really sound like one of these three theories. I don't know where it was. We have already eavesdropped on some of these interactions. In 2018, the Large Hadron Collider revealed particle processes in which the Higgs is produced along with the top quark and its antimatter equivalent, a top antiquark. The top quark is the most massive fundamental particle, heavier than even the Higgs, which means any deviations from the Standard Model should show up most prominently here. It's a great way to hit the Higgs hard and see if it does what we expect, says Thea Blickman at the Free University of Brussels in Belgium. Unfortunately, the top quark measurements reveal nothing untoward. The same was true in 2020, when we caught a glimpse of Higgs decaying into lower mass muons for the first time. What was it all? Untoward, I don't know what untoward means, but measuring the top quark haven't revealed anything untoward. Okay, that was it not, or at least was it not been found. And also was nothing found when they were able to let Higgs decay and capture it into the muons, which are lower mass than the one which they wanted the top quark, the top antiquark, the top quark. So far, the Higgs boson has shown itself to be resolutely vanilla. That is deeply frustrating, and yet the measurements at the Large Hadron Collider leave plenty of wiggle room to think that the Higgs is hiding something beneath its boring facade. Indeed, there is no shortage of ideas about what the Higgs really is and what it really does, and we don't have time yet. That means, if you were here for particle physics, you can go directly to the next part of particle physics, where we're going to read on and try to find out, I don't even know what that means, but whatever, if Higgs is it. If you stay here and participate in the standing yoga, then it's better to have your feet standing together and breathe in and lift the arms up. Again out. In the arms up. And out and out. in and up, and out and over to the side, in and up, and out to the other side, in and up. Make an inch of space between the feet and out again to the side. Then breathe in and come up on the tiptoes. And breathe out and sink down. This can go a bit onto the knees. In and up again. Out to the side, down onto the heels. In and up on the tiptoe. And out and down. In and up. Reach high. And out, bring the hands down onto the knees. Breathe in. And out and make a hill with the back. In into the middle. And out and make a valley with the back. Into the middle. And out, make a hill with the back. In into the middle. And out, make a valley. In into the middle. And out, come slowly with the joint back up and make it to the top of the shoulder. Breathe in, lift the arms up. Breathe out, come up on the tiptoes. And come down, feet together, and we come down the down diving dolphin. Breathe in, bend the right leg. And breathe out, stretch the left leg. Breathe in and change. Out, stretch the right leg. A mountain exercise. In and change. Out, stretch left leg. In and change. Out the right leg. Into the middle. Out and down. The penguin. Breathe in, lift the right hand up to the sky. Breathe out, bend the left knee and look up to the right hand. Inhale down. Out and down. Breathe in, lift the left hand up. Breathe out, bend the right knee and look to the left hand. In and back. Out and down. Make a hand of space between the feet. Shift the weight to the heels. Breathe in and come down the pelican. And out and up. In and down. Out and up. Take hold on the elbows and gently rock from side to side. The trebuchet is counterweighting. Hands again down, feet together. Breathe in halfway up with a straight back into monkey half lip. Out and down. In, halfway up. Out, down. And in, up again. The swan. The updiving swan and hands again down. The torso pointing to the outside. Will and have space between the heels. Breathe into the arms up. And breathe out and sink down. Elbows against the inside of your hip, of your knees. Breathe in, straighten up. And out and up slowly in one straight line upwards. Hands again down. Breathe out and breathe again in, hands up. Out again down. Breathe in, straighten up. And out come slowly in one straight line upwards. Legs wide apart. We're doing the diver. This exercise can go onto the back. Breathe again in. And out, lean the front. This can go onto the back. Make a round back. And come off a crown of the head. First up, arms to the side. And another time, but this can go to the back. Arms to the side, breathe in. And out, lean in front with the low, straight back, round back, come with a crown of the head first up. Have your feet standing together, breathe in, lift the arms up. And breathe out, lean back, drop the shoulder blades together, a crib in the morning. In and up. Out and back. Intertwine the fingers, reach high, screw. And out, reach in front, hold the back, the bowing curl snake. In and up. Walk us around. Out again in front. In and up. Out and back, drop the shoulders together. In and up. Out with long arms back, the sky up. In and up. And again, back, out, and up, out the arms down, breathe in the arms up, the eagle's wings, and out and down, in and up, out and down, In and up, the cactus collecting its stings in the evening, bring the hands to touch, allow the hands down to heart. That was the standing yoga. I thank you very much, and